Hello, everyone. Welcome to another one of our Day One and Beyond Did You Know sessions. In this webinar series, we focus on new features and enhancements of Oracle Cloud Infrastructure, and we also discuss how these solutions empower businesses to achieve greater efficiency, security, and scalability. Whether you're a seasoned OCI user or just getting started with your cloud journey, you're in the right place to explore what's new. My name is Taylor Zhang from the Oracle Personalized Training Team who puts on these Day One and Beyond sessions. For today's session, I'd like to welcome Tammy Bednar and Sean Stacy as we learn how to level up your application development with vector search.
Thank you, Taylor. Well, hello, everyone, and thank you for joining. Hopefully, some of you or most of you have seen Game of Thrones at one time or another. That was a very popular series on HBO. And hopefully, you have your screen in front of you. And if you look very closely, you may see a little blunder. So I'll give you a couple of seconds to look at that picture and see if you can see a blunder. No? Well, oops, look at that. You can see that red circle. There's a coffee cup. It looks like a Starbucks coffee cup. I don't think Starbucks was open at the same time when Game of Thrones was created back in the day. And so, anyway, as you can see, things happen, blunders happen. And so we thought that was a very interesting little fun fact that, the videographers had to go back and, of course, had to erase that little blunder itself. Why did we talk about that? Well, the challenges that we see today is that businesses struggle to process massive amounts of data, and they're efficiently analyzing the results, and then they can, with all that amount of data, that can lead to incorrect results and it can delay decisions. So, Sean, let's take a few look at the examples of what we mean by businesses that have large amounts of data.
Sure, and thank you, Tammy, for rolling me into this. So yeah, to tie in that blooper that we showed earlier, I mean, we're working with customers across all spectrums of industries, and believe it or not, we are working with film production companies who are looking at using Oracle technology to help them sort out problems, right? Traditionally, post-production operations involved manually viewing and scrolling through many hours of film footage, right? Making tasks like editing extremely manual and laborious, and finding problems like random mistakes or bloopers like the one we just saw was an extremely difficult task, right? That's just one example. Another example is the healthcare space. We're working with companies who are looking at solving problems and analyzing a vast, complex volumes of medical information. And oftentimes this leads to inconsistent decisions, right? Or worse, delayed care. So it's difficult for these systems today to find these subtle patterns, and especially when systems or information that these healthcare systems are working on, whether it's genome information or bacterial information or DNA information, is so large and overwhelming.
Yeah, and Sean, financial. I think this is important to everybody is money, but specifically, there are a lot of sophisticated hackers today that are having fraud in our accounts. And so that can run fraud against our accounts, I should say. And our banks are looking to try to detect that fraud and trying to keep pace with all these fraud tactics. And I'm very thankful because I know that sometimes when I have a transaction that happens, I get a text from my bank going, hey, did you really make this transaction? So this is an ongoing problem. And can you imagine financial transactions, how many transactions go on every day, millions and millions of transactions. So this is very, very important to not only our financial customers, but you as well as a customer of our banks.
Absolutely, Tammy. And really, this comes down to a common problem, right? That for decades, working with data has largely involved dealing with structured data. And customers have traditionally kept information like in our banking system, right? Our financial transactions are in rows and tables, etc. And when you need to find insights in your data, you often use things such as SQL, structured query language queries, or stored procedures to deliver those answers. But today, the expectations are much higher, right? Those three examples we just showed illustrates this, where the world is more connected, data is far more complicated, and it's an endless variety of formats, right? Scattered all over your business. It could be in the form of phone call scripts, images, social data, you name it. And really what we're seeing is that you need tools to find this data, right? To consume it, to easily make sense of it all. And capabilities like natural language processing, computer vision, and anomaly detection are becoming as essential as good old SQL queries to generate information and to learn and get value from your data.
That's a really good point, Sean. But today, our topic is vector search. So, what is a vector? Let's share with everybody what that is.
Yeah, absolutely. A good point, and thank you for bringing me back on task. So, yeah, what is a vector? So, really, as we've put here on this slide, right, a vector is a mathematical representation of digital data, whether that's an image, whether that's a text file or Word document or an audio. It doesn't matter, right? And what a vector provides you with the ability to do is to encode features, or if you wish, the semantic meaning of that data rather than the actual contents of the underlying words or pixels, right? And a vector is a list of numerical values, and they're referred to as dimensions in a specified format.
And I think AI is helping us to solve a lot of these business problems today with all this data. So, how does vector search work?
Yeah, great question again. So when we look at these dimensions, right, that are stored within these vectors, first of all, one thing I should point out, these vectors are created through transformers or embedding models or large deep learning and possibly even tying into large language models, right? And they run embedding algorithms and they create these vectors. And each one of these dimensions, so in this example, we can see this vector has 33, 42, 16, 21. Each one of those dimensions refers to a piece of metadata, and in this case, it's an image, right? So each number represents a different feature of this image of this house, right? So 33 is the type of roof, 42 is the facade or the decorations that are on that house, the number of stories, etc. And once we have these vectors created, we can perform what's called a similarity search. And as human beings, we instantly see the similarity, right, in these two images or three images that we have here. We can immediately see that the top two pictures on the top left-hand corner are more similar to the image on the right-hand side, right, in the lower right-hand corner.
Yeah, that's a good point, Sean. I mean, as humans, most of us can take a look and compare pictures. And so that's easy for us to figure out what's similar or not. But we need to provide a computer algorithm that allows this kind of comparison or similarity searches.
Yeah, exactly. So the distance between the vectors, that similarity, if you wish, where two of them are similar and they're not as similar as the other one, is basically calculated using similarity search math, right? So in this example, the images of similar houses will be closer together, while the image of that, what I would classify as a Japanese style house, is further away. And we can use maths to perform these operations once this image has been embedded and a vector has been created for it, right? So we can find semantically similar images, documents, or videos, all by simply calculating the distance between these vectors. Yeah, and then another way to view this, Tammy, is to consider that if we put this in a simple two-dimensional view, you may recall I mentioned that vectors can have many dimensions, right? A Oracle can support up to 65,000 or beyond 65,000 dimensions in a single vector. Now, in this example, we've just got a simple two-dimensional representation, and we'll simplify it by talking about terminology and words to help explain this. So as human beings, once again, we understand that strawberry, raspberry, plum, and apple are fruit. So those terms, the vectors, the mathematical representation of those terms would be located somewhat closer to one another versus states like New York, Texas, and California. Now, if we were to actually, say, perhaps perform a search for the word cat, we could say, hey, I'm looking for, and another thing is we could insert a new term like tiger, right? If we were to add a new term like tiger, it would naturally appear in this clustering of animals. But at the same time, if we were to now say, hey, I'm looking for everything, let's say the 5 closest matches to cat, I would definitely find the word cat. That's there. So I would have a 100% hit on that. And then the next 2 or 3 terms would more than likely be lion, tiger, and kitten, because we as human beings, once again, associate that there's a correlation, a semantic similarity between the term cat and tiger and kitten and lion. We're not sure what order that would come back in. Now, it might surprise you or it might not, but the 5th term would more than likely be dog or puppy. And that's because many of these embedding models are built upon information that's been trained from the internet, right? And there may be many terms where you would see the terms cat and dog in the same document, in the same paragraph, in the same blog article. Another way to think of this as well is I could enter the term tusk and I would get back the word elephant, right? So that's what this brings to the table.
I think I understand now what a vector is, and I think I understand how it works, which is pretty cool. So how can a customer take advantage of this very cool data type, the vector search data type, that's now just part of Oracle Database 23 AI?
Yeah, so that's another good question, Tammy. So first of all, in Oracle Database 23 AI, we're introducing a new native data type sitting inside the Oracle database to hold these vectors, right? It's a column that sits alongside your other columns of information. So information that's stored in your table could contain the house description, an ID for that house, as well as the vector for that house. So we've added that new vector data type. We've also added new SQL operations to work with vectors, anything from creating those vectors, calling embedding models and generating those vectors, to even querying those vectors. We've also added vector indexes for accelerating operations with vectors, right? So we've got in-memory indexes, we've got disk-based indexes, and we even have introduced something called a hybrid vector index. And in this slide, you can see how easy it is to perform a similarity search, right? We're looking for anything from this house is for sale based on an image that I'm providing. So I may have snapped a picture of a house, and I now want to look for houses that look similar. And I do this by saying order by vector distance, and that will do that similarity search operation. And at the same time, I can also say, hey, fetch me the first 10 rows only. So that way it's going to just give me those first 10 closest matches.
Oh, that's pretty cool, Sean. So that means that developers can easily combine what I call structured and unstructured data together. But vector search makes the search results even more intelligent, and that's what we expect today when we use our own when we use applications, right? However, I have a question. But aren't there specialized vector databases that can run these operations too?
You had to go there. That's a great point. But to be honest, we're doing things very differently. So first of all, it's great to know that I can pass a picture of a house and I can search for similar matching houses, right? And it makes a really good demo, as I'll show you later. But to be realistic, though, if someone's looking at an image of a house and they choose to look for houses for sale based on that image, that house looks Japanese in style to me, at least. And if my data set is built on data from all over the world, I'm probably going to get the 10 closest hits will be located in somewhere in Japan, like Tokyo, right? So that's not really going to help me. The other thing is my budget may be $100,000, and all of these houses may be way over the $1 million mark or more, right? So this is where the power of the Oracle database comes into play. First of all, we can have, remember, this vector is a column in my table. I can have another column that could be providing information such as the zip code, such as the location, etc. More importantly, though, and this is really important with Oracle, I can have that city and that price sitting in another table completely and do a native join through SQL and be able to filter out the data that's not relevant to me. So it's a very powerful and subtle thing that we're able to do. We give you the combination of both the relational model and the similarity search vector operations as well. And other vector databases just cannot provide this level of functionality.
Yeah, Sean, I think that's a really important part. There are other vector databases. We know that. And I think you just explained one more time, how is this any different from other vector databases?
Yeah, so other vector databases, there are some that do allow you to say, okay, if I've got a table with a vector column and I have my same table, but with my column for my city and price and whatever other information, I can filter out the information that's not relevant for me. But with Oracle, I can have that data sitting in another table altogether and do a join through SQL and remove or eradicate that data that's not relevant to my search query. That's just one simple example, and I'll talk about a few later on some other slides that we have coming up, Tammy.
Okay, fantastic. So, vector search, every mission critical feature of the Oracle database works transparently. This is an important point, transparently with AI vector search. And this allows our AI vectors to be used immediately in enterprise apps of any scale or criticality. And some of those mission critical features that I'm talking about that some of you may just think of right away are like real application clusters for clustered databases, parallel SQL, transactions, security, which is an all important part, especially if you're running in the cloud, analytics, and of course, disaster recovery for high availability. Now, one of these other important features that I want to talk about is Exadata Database Service. So the Exadata Database Service is running on the Exadata platform where we have intelligent software and hardware combined together to help you run your applications for everything that you are critical or that is critical for your mission critical applications, performance, availability, high availability. And if you take a look on the left-hand side, you can see all the database features that are available with your Exadata database service running the Oracle database. And of course, AI vector search is right at the top. Now, on the right-hand side are many unique algorithms that Exadata, and this gives its uniqueness to running your workloads on the Exadata database service platform, is giving you or providing you that all-important performance, reliability, and availability that you expect and need for all these mission-critical applications. So I'm going to just jump down a little bit further around vector search and how Exadata can actually provide another level of mission critical capability at any scale. So as I said, that Oracle's AI vector search can be transparently offloaded to the Exadata smart Exadata storage for up to 30 times faster AI vector queries. So how does that work? If you look at the picture on the left-hand side, the Exadata platform is made up of smart Exadata storage. And when I say that, that's because it's not just storage. We actually have processing power in these Exadata storage servers where we can offload these queries to the processing into the storage servers and then pass that result set into our database servers, and where our database servers take those queries and parallelize them or put them together for the result set that makes it very, very fast. So the vector search queries automatically parallelize across all the storage servers that you have in your Exadata database server service. And then each storage server independently computes those top K matches that Sean was talking about. And that enables faster top K processing. So that's how Exadata, and just one of the smart algorithms on the Exadata platform, can provide much, much faster AI vector queries. And of course, it supports extreme scale environments with thousands of concurrent AI vector searches. So Sean, I think you have a couple of very cool demos on vector search that hopefully will bring this home for everybody today.
Yes, I do, Tammy. So the first thing I'm going to do, I'm running a Python program here, and I'm going to create a table called My Data, and I will do a select star from my data. I should also describe it. I'll do that in a second. I've got 150 entries here, 150 entries, and they're just random factoids. I've got some things about some places in the US. I've got some things about some fruit, some cars, etc. And I'll describe the table so you can see what a vector looks like. And in my case, I'm simply just defining it as a star dot star or a wildcard. I'm not defining it, but I could specify the number of dimensions, etc. Once I've got that table created, I'm now going to vectorize my data, and I'm going to use a sentence transformer, and I'm going to embed it with a multilingual embedding model, right? So this is being run from Python, but it's connecting to my Oracle database, taking those facts that I had, my 150 facts, and creating a vector or embedding that data into a vector. So if we jump back and now select my data from the table, whoopsie, you should see, and I'm intentionally doing it live so you can see that I've got some typo, but here's a vector, right? So Antarctica is very cold. That's what the vector looks like. Now it's not showing me the whole string because it's over 380 dimensions to it. But now that I've got that, I can actually run a quick query, and let's do a similarity search. And I'm making sure to use the same multilingual model against it. Now, this is where it gets interesting. I can type the word cars, and I've pulled out 5 factoids from my data set, which, if you look up here, I've got some entries about cars. Now, what's really interesting for people who are used to relational tables and running SQL is the word cars does not appear anywhere in any of these strings. Now, this is where it gets interesting. I am not good at French or anything, but I know the French word for cars is voiture. And look, voila, I've got some cars. I could also say coche, which is Spanish for cars, and here we go. I could also say sailboat, and I've got some entries for sailboats. And I could say voilier, which is French for sailboat, and here you go. I've got some results there. So you can see the power of similarity search, hopefully, Tammy, with what we're able to do there. Now, I know we don't have a lot of time, but I do want to show you one last demo if I can, Tammy. And that's
Sure.
great. So I'm using the same data set in this one, but I've pre-recorded it just because this one runs on my laptop because of the video drivers. So I'm just running it on so basically what I'm doing here is I'm pasting a URL from a website. I just typed in the word America's Cup and I went to the website. You could see I recorded this a little while ago because the America's Cup is over now, but I was just looking for an image. So I grabbed that image and I'm pasting that image there, that JPEG, and I've loaded it up. And now I'm sharding it. I'm chopping it into small pieces that I can then run that embedding model against. And once I've done that, guess what? I can similarity search against my Oracle database, and I'm pulling back these same entries. So hopefully that shows you the power of what we're able to do here.
That's very cool, Sean. I love the multilingual one. I think that's pretty cool.
Thank you.
So, Sean, I think we can see that Oracle AI Vector Search powers the modern enterprise today, and it is seamlessly integrated with Oracle Database 23 AI, the database features to provide enterprise-grade performance and reliability that our customers expect from Oracle. And not only is it integrated into mission-critical enterprise capabilities like Exadata Cloud, but also SQL processing that makes it easier for our developers to create modern applications.
You make a really good point. And basically, at the end of the day, AI vector search and similarity search is really able to take advantage of SQL processing, right? And with Oracle's Converged Database, it's possible to combine the power of AI vector search with all of these converged benefits, as you illustrated with the Exadata platform, right? We're able to bring the power from machine learning models to spatial to property graphs, all from one single location. You never, ever need to leave the database to get these benefits. And to tie it back to our fun factoid at the very start, right? In the case of our customer using, I'm working with a customer actually that's using vectors, and they happen to be in the movie industry. And they were able to migrate their solution running in one of those specialized vector databases to Oracle. And the reason they did this was that they had 2 separate data stores. They had their vector database and they had a relational database. They were able to migrate all of that because of our converged story, move that into one single place. Furthermore, they were able to move it, or they have moved it, to an Exadata platform. So they're able to see even faster performance gains. And we're talking about orders of magnitude faster than their old multi-system setup. So as a result, their production costs have dropped significantly because the time required in the editing room is reduced significantly. So we're helping customers solve problems in all walks of life, so to speak.
And they're real life problems too.
Absolutely.
Okay, so here is some links so you can try vector search for yourself. Hopefully, if you haven't heard of Oracle Live Labs, or if you've used them before, here's some direct links to some labs, live labs specifically on AI vector search. And here's the link to the documentation. I'm running Oracle on Exadata today. Is this functionally available on premises today? So yes, if you go run on Exadata on premises today, you can run Oracle Database 23 AI, and all the functionality that Sean and I talked about today with AI vector search is available there, and you can easily use that as well. Does Oracle have a limit on the size that a vector can be in the Oracle database?
That's a good question. No, there isn't. So first of all, I mentioned earlier, right, the number of dimensions that a vector can have is 65,535. But furthermore, the size or the number of vectors that you can have in a table is unlimited. It's no different to the number of rows you would have in a table. It's just another column or data type.
Question, is AI vector search the only AI feature available in the Oracle database today?
No, it's not. So we just talked about similarity search and AI vector search and everything that's there to support that. But we also have an awesome feature called Select AI, which literally lets you use text to speech or speech to text, whichever way you want to do it, to actually query your database using natural language. So you can type in like whatever terms you want, and it will actually go against your own set of data without leaving your database to query it. So that's one thing. And then we've also had, for many years, over 20 years, we have over more than 30 embedding models and different types of data mining models that are built into the database. We have an Apache Zeppelin-based notebook if you're running on Autonomous Database to access those services.
Yeah, thank you so much, Sean and Tammy, for teaching us about vector search today. I definitely learned a lot and hope you did as well. Thank you so much for joining.